Alright, hello everybody. Okay, so third topic for Unit 2, speed versus velocity. Okay, so if you notice, if you already looked at it, the equation is the same for both. Okay, but the difference is here. So you have speed, you have velocity. Okay, speed, all speed is distance divided by time. Okay, while velocity is displacement divided by time. Okay, so you have distance and then you have displacement. Remember, displacement is going to be the change in position. Okay, so that start to finish, that change in position. Okay, here's another difference. Velocity has direction. It has direction, so left, right, up, down, north, south, east, or west. Okay, speed doesn't have direction, so no direction. Okay, but here's your equation. Okay, so they're the same. You still have d divided by t. Okay, whether it's for velocity or it's for speed. Okay, but main thing is that they're both measured in meters per second. Okay, meters per second. That is your unit. You have to have your unit when you're working these equations. Meters per second. Okay. Alright. So let's do an example that you guys have. Oh, here. Another thing, okay? So speed, we learned from the last one, is going to be scalar. Okay. Velocity, vector. Alright, so you notice S and S, V and V. Okay, scalar, that means that it has a measurement. Okay, but it has no direction. Exactly what we have here. Speed has a measurement, but no direction. Velocity is a vector. Okay, you have a measurement with a definite direction. Alright. So let's talk about on your notes. Okay, you have this train example. So it says, suppose the train is moving at a constant rate of 5 meters per second. Alright. So in looking at this, okay, notice it says constant rate of 5 meters per second. Alright. So was the train speed constant? Yes. Okay. Why is it constant? Remember, speed has no direction. If you look at this course, okay, it is a oval course. Okay, so it changes direction. So speed is constant, yes, because the train can be going constantly at 5 meters per second. Okay, was the train's velocity constant? We're going to put no. Okay, the reason this is a no is because, remember, velocity has direction. Okay, so if you look at this course, it is an oval. So every time the train comes around this corner, it's already changing direction. Okay, that means your velocity is not constant. Okay, every time it comes around, it changes direction. Okay, so the velocity cannot be constant. Direction changes, velocity changes. Okay. So we're going to continue work on these problems. In 2009, Usain Bolt of Jamaica set a world record of 9.58 seconds in the 100-meter dash. What was his average speed? Okay, you have your little chart up here. This should be able to help you with this equation for this test. Okay, so average speed. Speed is equal to distance divided by time. Okay, we're going to plug in our numbers. Our distance was 100 divided by our time. Okay, what will help you guys is if you label what you're given. Okay, so 100 meters. Remember, don't forget your units, meters, and then you have 9.58 seconds. All right, so put that into your calculator. 100 divided by 9.58. Okay. So you should be getting 10.438. So we're going to round it 10.44 meters per second. Remember, do not forget your units right here. Okay, have to have your units. All right. So, question 2, okay? An athlete sprints 50 meters in 60 seconds, stops, then walks back slowly to the starting line in 20 seconds. Draw vector diagrams to show the position of the athlete. Okay, if the direction of the sprint is considered to be positive, calculate the following. So, this is what we're going to do first. We're going to underline and label. 50 meters our distance. 6 seconds is our time. We're given 20 seconds also. That's our time. So your sprint velocity, okay, his displacement divided by his time. So for the sprint, he went 50 meters in 6 seconds, okay? So put it into your calculators. You're going to get 8.33. And remember, he sprinted, so if anything, draw all your vectors, okay? He sprinted. Anytime you sprint, okay, here's your starting point, you sprint. Okay, it's going towards my right. Okay, so like on a graph, if you go towards your right, it's positive. Okay, so his velocity is going to be 8.33 meters per second, okay? And he's going towards the right, so you're sprinting. It's a positive direction, okay? So velocity for the walk. Velocity divided by time. Displacement divided by time. Okay. So now, let's look at it. It says stops and then walks back slowly to the starting line in 20 seconds. Okay. So he sprints 50 forward, and now he's going to end up walking 50 back to the starting line. So you have 50 meters divided by, it took him 20 seconds to walk back. Okay, so now you draw your vectors, okay? He's walking back, so it's walking backwards now. It's walking back this way. Okay, so if we said this was positive, this is going to be what? It's going to be negative. Okay, so 50 divided by 20, you're going to end up with 2.5, okay? So it's going to be negative 2.5 meters per second, okay? Why is it negative? He walked backwards, okay? Now, average velocity for the total journey, okay? Velocity is equal to your displacement divided by your time, okay? So displacement, remember, start to finish. So he started at 50, right? He went positive, and then he went back 50. So remember, anytime vectors are in opposite directions, Okay, opposite directions, you're going to subtract. Okay, his total time, you're going to add up his time. You have 20 seconds for him walking plus 6 seconds. Okay, so 50 minus 50 is 0 meters divided by 26 seconds. Okay, what are you going to obviously get? Okay, 0 divided by 26 is still going to be 0 meters per second. That's your average velocity for the total journey. Remember, displacement, start to finish. He started going 50, and then he came back 50. Remember, opposite directions. You need to remember that for your vectors. You have to subtract. Okay? Now, let's flip this over. Okay, distance traveled. What's the total distance he traveled? Okay, so remember, he did 50 meters sprint, and then he did 50 meters coming back. And we're just talking about distance, right? So that means we are just going to end up adding up his total ground cover. So 50 plus 50, his total ground cover, okay, is going to equal to 100 meters. Alright, now we're going to work on average speed. Remember, speed, we don't care about direction, right? And yeah, speed is equal to your distance divided by your time. So now we know his total distance, total ground he covered was 100 meters. Okay, we learned from the last problem, okay, our last problem, remember, right down here, his total time for everything was 26 seconds. Okay, so that's all you're gonna have to do. 100 divided by 26 in your calculators. You get 3.846. We're around at 3.85 meters per second. Please do not forget your units. Okay, if you don't have your units, it will be counted wrong. It is wrong if you have no units in it at all. Okay, so that's how you do it. Okay, main part that you need to remember, the main thing. Okay, we're gonna go back to this. Speed is a scalar, so it has no direction. Okay, velocity does have a definite direction, and it's about displacement. So anytime you deal with velocity in your equations, in any of these equations, any of these word problems, I want you to draw your vectors. You need to draw your vectors so that you can visually be able to see it and not try to imagine it in your head. Okay? So that is the video for speed and velocity. Okay, in another video, I'll work on some of the problems throughout this whole packet. If you guys can send me what problems you guys need me to work on. Other than that, that is it. Okay, if you have any questions, make sure you message me. Let me know what's going on. Bye, guys.